Okay, guys, so for day 5, this is the only, you'll notice this is just it in your packet, is just this one question. It's still talking about a stem plot, but it's going to be what's called a back-to-back stem plot. So this is just one more way to represent data, especially when we have two different categories that might have similar data that's kind of close to each other. In this case, we're going to use our data we collected. So I want to be referring back to this. To compare the heights of males and females. The stem plot we did so far, if I have it here somewhere, where'd it go? The stem plot we did so far did not designate if it was male, if it was female, we just had heights. What you can do with the back-to-back stem plot is separate it out so we can see, based on these different variables, what data we have. So what a back-to-back stem plot looks like is normally we just have the one line and then our stems over here on the left. We actually draw two lines and then put our stems in the middle. Now, if we look at our data here, I do want you to do, for a reason, I do want you to do all of our data. So you're going to take a moment to do that. We talked about we need to round these. We're going to go ahead and round these to the nearest whole number. So we'll round that to 66. Oh, I forget that I have my finger that I can write with because I have a touch screen. We're going to round that to 61, round that to 68. Let's see, any others, we'll round that to 64. So as we're looking through, remember that we need to create as many stems as we have data for. Now, we talked about before that we kind of want to separate our data out a little bit, so we have plenty of stems. Remember, now that I'm asking you to use all of our data, we do have that one weird outlier of the person who wrote their height wrong and put 36 inches. So we are going to include that in our stem plot. So what that means is my first stem is going to be 3. We again are going to separate these out so we have more stems. Again, that allows us to see the data a lot better. So this 3 is going to represent, just for us, 30 to 34. Remember how we did that? We'll do one more 3. That's going to represent 35 to 39. Then we'll have, going on from here, 2 4s. Going to keep extending. I keep forgetting that I can write with my finger. We got 2 5s, 2 6s, and 2 7s, because that's pretty much all of our heights. We got no one in the 80s, right? Now, we also don't have anybody in the 4s, as far as I know. Yes, nobody in the 4s, but we can't skip that. Because we have somebody in the 30s, you have to include those 4s, and we're just going to leave them blank. So what we do is, from here, we're going to label the left side our males, or females, it don't matter. And the right side is going to be females for our purposes. The leaves now are going to stem from the center outwards. So we talked about kind of one of the tedious things about stem plots is that you have to order the data. We know that, again, on the female side, it's going to go increasing out in this direction. On the male side, the opposite, it's going to go the opposite way. So it's going to go increasing out from the center. So for example, if we had a 40 and a 41 for males, which is short, but whatever, I would put the 0 closest to my stem and then the 1. We put them in order going outside from the stem. So I'm going to do a couple, and I'm going to kind of let you keep going from there. And again, we're splitting our stems here so that we can see the distribution a bit better. Remember that this is, again, 30 to 34, 35 to 39, 40 to 44, 45 to 49, so forth and so on. So let's do the first few. So what I'm going to do here, and I'm going to cut this part out of the video of me putting this together so you don't have to wait for me to do it. I'm going to go through and I'm going to highlight all of my male categories. You might want to circle them as well. We don't have a lot of males in this class. We got 1, 2, 3, 4, 5, 6, 7, 8, 9 that are included in this distribution at least. I think we got a couple more in class actually. So I'm going to take all of my male data and I'm going to go ahead and put that on my stem and leaf plot. So let's see. Well, the smallest one I have so far is the 36, that weird outlier. So we'll come back here. I have a 36. So where would that go? I've got 2 3s. Where am I going to put the 6 though? It should be on the second one because that represents from 35 to 39, not the first one. That's 30 to 34. So we put our 6 there. There is our first one, all good to go. And let's see, do I have any 50s or 40s? Nope. But I've got 60s. So let's see what I've got. Let's check our 60 to 64. But do I have any? Yep, I've got one male at 64. Any others? Nope, okay. So once again, I'm going to scroll down here. Where would I put the 4 between these 2 6s for my stems? It's going to go on the first one here because, again, this 6 represents 60 to 64. I want you to keep going from here, getting all of our males' heights on the stem and leaf plot, again, growing outwards and reordering as necessary. So try that just for the males, and then we'll come back and check. I'm going to cut this part out of video. Let's see, I got a 68. Let's see, I've got 165, 2 67s, 65, 67. I can use my finger. 67 over Pete's. 65, 2 67s, and then a 68. And then for my 70s, I've got 3 71s. 1, 2, 3. 1, 2, 3. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I have my male distribution done. So we can see again that it's kind of flip-flopped from how we normally see a stem plot, with our numbers increasing going outwards from our stem. So this is what we should have. We've got a 36, a 64, 65, 67, 67. You kind of have to read it backwards now, right? This isn't 17, that's 71. Okay, now I want you to try it for the females. Same thing, make sure you're rounding everything up. Hopefully we can go from there and get our female distribution, and then we can talk about comparing these two different distributions. So let's see, I've got, this is a 66. That's a 68, that's a 64. Okay, I have some 50s. I have a 51. I have a 58 and a 59. 58 and a 59. I have, oh, that's a 61. I have a 60. And a 61. 1, 2, 3, 4. 4 61s. 1, 2, 3, 4. I have 1, 2, 3, 4 62s. 1, 1, 2, 3, 4. I have 1, 2, 63s. I've got 1, 2, 3, 4 64s. Holy crap. 1, 2, 3, 4. I've got any 65s. I got 1, 2, 2 65s. I've got 1, 2, 3 66s, 66s, and 168, right? 16. Oh crap, that one's not. That one's male. And I think that everybody. Did I get that male? 16. I did. Okay. Okay, so we can check our distribution really quickly here. If you can take a second to check, I'm pretty sure I didn't miss anything. But again, we can see that I have it in order. Took me a while to do. But now that we have our distribution, now we can compare these distributions. So don't forget, whenever you are comparing distributions or talking about distributions, you have to remember your SOCs, right? So take a moment and look over your notes, but see if you remember. SOCs, SOCS, stands for the things we need to talk about. SOCS. Sorry for my terrible handwriting. Oh my gosh. See if you can remember what SOCS stands for. We have shape, outliers, if any, gaps and clusters kind of falls in that category, center, and spread. So we are just going to write a couple sentences describing these distributions and comparing them, see if we have any similarities. So let's talk about the shape of both of these distributions. Now, I meant a couple had asked about this. What do we talk when we're talking about shape on a stem plot? How do you talk about that? What you want to do is look at it sideways. If I, for example, my vertical line here, if I'm looking at it now like it's a horizontal line, here's kind of the shape of my distribution for females. Let me use my finger. I keep forgetting. There we go. That's the shape of my distribution for females, right? On the other side, again, if you turn your head sideways, you can see it better. On the other side, let's kind of follow our distribution here. We got this weird outlier. Womp. There's the shape of my distribution there. So let's look at those two shapes. What do we think for the male distribution? Do we want to call that symmetric, skewed, uniform? What do we think for that? This is probably going to be skewed because we've got this long tail on the end here, right? Now, if you're turning your head again to look at that, would this be skewed right or skewed left? Remember, it's where the tail is at. That's going to be skewed to the right because that's where our tail is at, on the right side. If you're turning your head to look at our distribution, that's going to be on the right. So we can say males distribution is skewed right because of that outlier. Kind of weird. We're clustered here on the left side and we have this weird outlier here. Yeah, that makes sense because most males are going to be a bit taller with some outliers that are a bit shorter. So that would skew us towards the right. For the females, what do we think? Now this one's kind of weird because we've got really kind of a lot here in those early 60s. But you can kind of have your choice here. Again, it's kind of an opinion when we're not doing it mathematically. What do you want to call that distribution? If you said symmetric or slightly skewed left, you could say that. So females, symmetric, I would accept. Again, right now we're just getting used to using these terms and we're just kind of looking at it ourselves. Or slightly skewed left. Slightly skewed left. We could say that. So this is our shape. Let me, oops, come on. This is for shape. Crap, I'm gonna have to delete this and try again. Not the whole video, just this part. Because you can't look at it that way. How do I want to attack this? It's hard when the data doesn't look pretty. I'm gonna cut all this out of the video. Okay, I'm gonna try again. Okay, thank you. Okay, sorry, I had to cut out a section there. So let's go back to this. So for socks, once again, we have our first letter S standing for shape. Now it's kind of hard to tell shape when we're looking at these stem plots, especially because depending on the way you're looking at it, it doesn't quite line up with how we're used to looking at data, i.e. increasing from left to right. But what we can do with this data, especially if we ignore this outlier here, it ends up working out okay for us if we follow the distribution of the data, kind of create a little line here, whoop, that's kind of the shape of our distribution. If you turn your head sideways, you can see the curve it makes, like the pictures that we drew in our notes. Same thing here, if we ignore this outlier out here, that's basically the distribution of our data. So looking at how I drew those two curves, if we were to put them on an actual graph and make a curve like that, they might follow about that shape. What do those look like? Again, we had our options being symmetric, skewed right, skewed left, or uniform. What do both of those kind of look like to you? They're about symmetric. The guys you might be able to say are skewed a little bit, same with the girls, but they're roughly symmetric. We do have some outliers that kind of throw us off, but we can say both our distributions are roughly symmetric. Distributions are roughly symmetric. Right now, again, we're just getting used to kind of working with these terms. Mathematically, we'll be able to say later if it's symmetric or skewed right or skewed left. But for right now, we can say that, and that's okay. So there is our shape. They're roughly symmetric. The O stands for outliers, which we do have a possible one, right? Looking at our data here, do we have any possible outliers? That 36, again, is we know someone is not 3 feet tall in our class. That 36 is an outlier. And mathematically, again, later, we'll have a way of determining if something is an outlier. So for right now, if we're not doing any math to determine that, we're just going to say there is a possible outlier for males at 36 inches. Probably we don't have somebody who's 3 feet tall. We'd probably know that. And no outliers for females. You want to mention both. Then we said that C stands for center. Now again, we are just kind of eyeballing this right now, so take a moment to look at your stem plot and pick a center for both distributions, somewhere roughly in the middle. I'm going to pick one. It might be pretty close to yours. You don't need to change it if that's the case. We're just eyeballing it. So what do you say for your centers for both these distributions? So for men, I might say 67. I'm going to go ahead and say that. Males, center is roughly 67 inches. And for females, I'm going to say, let's go 63 inches. Females' center is 63 inches. Again, we're just eyeballing. If you said 68 and 64 or something like that, that's okay. And the last S stands for spread. So this we can do exactly here. Because again, mathematically, right now, spread is just the range. We need to say from this number to this number, from this number to this number. So take a minute, write your spread for males and your spread for females. Okay, for males, it goes from 36 to 71. Males' spread is from 36 inches to 71 inches. And the female spread is 51 to 66. Oops. I said 51. DH. 51. I can do this, I swear. 1 inches to 66. There we go. Okay, so again, whenever they say to compare the distributions, we can just list. You don't have to say, well, it's this, but this. Here's the similarities, here's the differences. We can go one by one and list out describing both. Again, we did say they kind of have a similarity here, that they're both roughly symmetric. But if that's not the case, that they're not similar in any way, you can just say, here's what this one is, here's what this one is, and go piece by piece. So on your guys' homework, it is just practicing with these back-to-back stem plots, and that's it. If you have anything else you need to get caught up on, though, if you're missing any other assignments that you still need to submit, you guys can take the rest of the time to do that.